So now that we know how to find our way around in these coordinate systems, really the most important thing about a graph is not just how the graph looks, but what the graph tells you about an equation, or if you're in a different math class, you might think of it as a function, but we're not going to. What the graph illustrates about an equation that involves the two quantities x and y. So the big skill here is to be able to take an equation that has both an x and a y in it, and from that equation generate the basic shape of the graph that corresponds to that equation. So for example, just to get us started, let's suppose I take this equation on the right of the example, which is on the window side. So y equals x squared plus 4. Suppose for a moment that I want to come up with some points in this coordinate system whose x and y coordinates satisfy that equation, y equals x squared plus 4. So what it means to graph an equation is just that. It means to show which ordered pairs, x and y, so which x and y, satisfy the equation, y equals x squared plus 4. But this equation has two different variables in it, right? It's got an x variable in it and a y variable in it. So how are we going to come up with some points which meet this criteria? Because this equation has two different quantities in it, two variables, we can't get anywhere until we specify some values for one of them, right? In other words, we get to choose, or maybe your professor gets to choose sometimes, maybe you do. We get to choose some values for either x or y. And whatever values we choose, we can plug into this equation and figure out what corresponding value for the other variable exists because of our choices. So for example, I can't just choose x to be 0 in this equation without thereby giving y a specific value, namely whatever value y will have when the value of x is equal to 0. So let's do that as an example. So if x is equal to 0, I'm going to keep track of this up in the chart, up in the upper left, then what is y equals x squared plus 4 going to tell us about the value for y? If x is equal to 0, what am I supposed to do? Plug in a 0 for x, and then follow through the consequences of that choice to figure out what value y then takes. In this example, it's straightforward arithmetic. All I have to do is evaluate what's on the right-hand side. Y equals 0 squared plus 4. What operation do I have to do first here to evaluate this? How do you evaluate 0 squared plus 4? Exponent first. Order of operations is going to tell us that the exponent, what is 0 squared, by the way? 0 times 0, right, which is 0. The exponent has to come first, and then what comes last? Addition. Great. So what that tells us is that if the value of x is 0, then the value of y, which corresponds to that value of x, is 4. So in my table up here, my table of data, I'm just going to write underneath where x is equal to 0, I'm going to write y is equal to 4. Okay. And now how do I visually show that point on my graph? What ordered pair are we talking about here? Say again?
Wait, do you want to know where it is?
Yeah, that's all I'm asking. And why is it on the right side? It what is positive? That here. So when we're asking about an ordered pair, every ordered pair is going to have a value for x and a value for y. What's the value for x that we had in this example? X was 0 and y is 4. So what we should do then is find out where the point 0, 4 belongs on this graph. I'm going to again set down a scale for each of my axes, and this time I am going to choose it to be the same for the x as it is for the y, just for the sake of convenience. So on the x-axis, let's suppose that we're counting by ones. On the y-axis, let's suppose that we're counting by ones. Where am I going to find the point 0, 4? Say again? starting from the origin, right, which is always a good plan. Everything should start from the origin. And from the origin, which way should I go? Right. So I don't want to go left and I don't want to go right because my x is 0. Therefore, I'm not going to move any horizontal distance, either to the left or to the right. But my y is 4, so which direction do I need to move?
On the Y line?
Up, exactly. Directly up along the y-axis 4 units, I will find the point 0, comma 4. So all I have to do is go up that way, and I find the point that I was looking for. Whoops. 0, comma 4. So that shows me one point. That gives me one relationship between the variables x and y that are suggested by the equation y equals x squared plus 4. But if I want to get a better sense of the relationship between x and y that's suggested by that equation, I have to do this a few more times if I want to know what the basic shape of this graph looks like. I have to do it not just for a single value of x, not just for 2 values of x, but probably for a whole bunch of different values of x. And so the task that I'm going to set you to in your groups in a minute is to do this process for both of the equations that I've asked you to kind of compare and contrast, right? On the window side, we have the equation y equals x squared plus 4, the one we just looked at, as well as the equation y equals x plus 2, the quantity squared. So you'll get to look at those and graph all of those points on a set of axes of your choosing. And likewise, on the wall side, I've given you 2 different equations to investigate the values of x and y for, and to sketch the points that those suggest. And in each case, I've supplied you with x values to test, so you don't have to dream them up. But I reserve the right in other circumstances to not always supply you with x values and ask you to do your own. But just to get you started, use the x values that I've given you, the equations relating y's to x's to complete these data tables, and sketch the shapes of your graphs. So let's start looking at these 2 examples. Actually, it's really 4 examples. By getting down the coordinates, the ordered pair coordinates of the points that we started with. So starting with the graph on the left, in the first equation, y equals a quantity x plus 2 squared. So for that equation, what did you get for your y coordinates for the 5 x values that are shown? If x is negative 4 for that equation, this equation right here, then what is y? Window side. So if x is negative 4, we find out that y should be positive 4. And that's why, on this graph, you had the ordered pair negative 4, 4. That's that point right there. Right? If x is negative 2, you ended up with 0 for y. If x is 0, 0 plus 2 squared ends up being positive 4. If x is 2, 2 plus 2, the quantity squared, that's 4 squared is 16, which means, by the way, that I think this point is a little bit out of place right here. This point looks like 2 comma 8. 2 comma 16 is somewhere off the grid, unfortunately. It's probably up here somewhere. And the story gets even worse when x is equal to 4, because then 4 plus 2 squared is 6 squared, or 36. And so that point is way up here somewhere. Who knows? We've got a lot of room to play with here. But anyway, the point is that if I take that first equation, y equals x plus 2 squared, and I endeavor to connect the dots, then connecting those dots is going to give me a shape that kind of looks like that. Okay? So that's my first equation, y equals x plus 2 squared. We can get a sense of that basic shape just by picking some x values, which I've done for you here, and then plugging those x values into the equation to turn them into y's, and turning those x's and y's into ordered pairs on the graph, and then connecting the dots. So that's for the first equation. The second equation, y equals x squared plus 4, what were the y values that we got for this? So we already said before, we worked this example out, that when x is 0, y is 4, which gives us, again, that same point right here, 0 comma 4. But if we look at the other values, let's say x is equal to negative 4. If x is negative 4, then what does y evaluate to? And again, as I mentioned to your groups as we walked around, I walked around today, don't forget that when you're substituting a number into an expression to evaluate it, hug it with parentheses. Otherwise, you may end up making a sign error. Jamie? Negative 4, the quantity squared is 16. 16 plus 4, that's 20. So choosing to go one by one on this grid has actually kind of come back to bite me here, because we don't really have quite enough room to show the locations of all of these points. But negative 4 comma 20 would then be the coordinates of that point. If x is negative 2, then negative 2, the quantity squared, is 4, plus 4 is 8. So there we're going to get the point negative 2 comma 8. So 2 to the left and 8 up puts us right here. Nope, that's 1 too far down. Negative 2, 8 is the point that corresponds to the x value of negative 2 on my second equation. The same thing happens if I plug x equals 2 into this expression. 2 squared is 4, plus 4 is 8. And so I get the point 2 comma 8 to be a part of our second equation. And finally, if x is equal to 4, 4 squared is 16, plus 4 is 20. And so again, we get this point, which is sort of way up here off of our graph. But when we connect those dots, the picture emerges of a graph that looks like that. So there are the graphs of these two different equations. And now I have to ask you the follow-up question. Based on what these two graphs look like, is it true that the expression x plus 2, the quantity squared, and the expression x squared plus 4 are equivalent? Yes or no? No. Why not? The graphs are different. So we've actually, this is a question we've come back to over and over again this semester. Is it possible to just distribute this power, the second power, across into the parentheses? Because that's what it would look to be the relationship between these two equations, these two expressions, right? But here is another verification that those are not the same thing. Right? Because the graphs are different. The graphs have different points on them. They have kind of the same basic shape, if you notice. They both have this kind of U or V shape to them, but not made up of the same points. So these two expressions cannot be equivalent expressions. How about the expressions that are over here on the right? Let's get the table of data down. Starting with y equals 4 minus x squared over x plus 2. So starting with that first equation. Someone want to read off their y values that you got for that equation, for the given x values, negative 6, negative 3, 0, 3, 6? 8, 5, 2, negative 1, negative 4. Is that what everybody got for these? Okay, cool. And so those points are actually the self-same points that I've already kind of sketched up here. This one, that one, that one, and that one, and that one. And now someone else from the wall side, read off your y values that you got for the equation y equals 2 minus x. What'd you get for that one? The same. So you got 8, 5, 2, negative 1, negative 4. And if I plot those points, I'm going to be plotting them in exactly the same spot as the ones that we just plotted. So if we connect these dots, first of all, what shape does this graph end up taking? Yeah, unlike the examples on the left, this graph takes the shape of a straight line. That straight line. So that's the first thing that we notice that's different about the equations on the left compared to the ones on the right. The equations on the left seem to give us some kind of a curvy shape. The equations on the right are giving us a shape that looks like a straight line. That's the first observation. Now let's go to the second observation. According to what we're seeing in this picture, is the expression 4 minus x squared over x plus 2 and the expression 2 minus x equivalent? According to what we see, it looks like they're equivalent. And why is that? They're the same graph. They're the same points. For all the x values that we've chosen, at least, I'm going to hedge my bets a little bit and say could be equivalent. For all the x values that we chose, both of those expressions have the same y value. Right? And so as far as we can tell, these two expressions could be equivalent to one another. But just to throw a wrench into your works, I'm going to encourage you to try at home the value x equals 2 and see what happens. That may end up upending your answer to that just a little bit.